So in this example problem, we're asked to determine what is the bridge constant kappa for two string gauges that are mounted on a structurally member that's shown on the left hand side here. So in this one, we have one strain gauge that is going along the direction where the force is being applied here, and that's in position 1 of our Wheatstone bridge. Alright, and in position 2 of our Wheatstone bridge, we have one that's going in the lateral direction, so in the Poisson's direction. Okay, so, alright, the strain that's experienced by strain gauge 1, we define it as being equal to our axial strain. Alright, strain gauge 2, our strain gauge is going to be equal to the lateral strain, which we can relate using the Poisson's ratio and the original axial strain. Alright, so, alright, if we assume that all the resistances are equal, so we can say that R1 is equal to R2 is equal to R3 is equal to R4. Alright, alright, and we can say that our gauge factors for both of our strain gauges are equal. Alright, we want to determine what is our value for kappa. Okay, so, alright, we know, alright, from last lecture that the change in resistance, our strain gauge, over the original resistance is equal to the gauge factor, alright, times the of that strain gauge times the strain within that strain gauge. Okay, so, alright, now we can do the same, repeat the same process for strain gauge 2. So we can say that delta R2 over R2 is going to be equal to our gauge factor of strain gauge 2 times the strain within strain gauge 2. Now, we can plug in the values of strain that we defined earlier here. So we can rearrange this as being the gauge factor 1 times the axial strain for the first strain gauge. For the second strain gauge, we can say that it's going to be gauge factor 2. We're going to replace with gauge factor 1, and we're going to replace E2 with minus the Poisson's ratio times EA. Okay. Now, what we can then do, all right, we know that from earlier, again, last lecture, if we had only a single gauge, right? So for only a single gauge, we know that the change in the output voltage over the input voltage would be proportional to delta R1 over R1 divided by 4, right? Which we also know if we plugged in the value for delta R1, alright, we would get the gauge factor 1 times the axial strain over 4. Okay? Alright. So for a but since we're using multiple gauges, right, the equation is no longer applicable. So, right, so for multiple gauges, we know that the relationship delta EO over EI is going to be equal to the change in resistance. All right, is going to be equal to, let's see here, is going to be equal to, let's see here, is going to be equal to delta, it's going to be equal to, sorry, give me a second here. All right, it's going to be equal to the gauge factor over 4 times E1 minus E2 plus E4 minus E3. Now, E3 and E4 don't exist, so we can treat that as being 0. All right. So if we plug in the values of E1 and E2 here, we get we would get the gauge factor over 4 times EA minus the Poisson's ratio times epsilon A. Alright, so we can simplify this down further. We can take out epsilon A over 4. Alright, and and the gauge factor, and we just have a 1 plus the Poisson's ratio. Okay. Now, if we divide the delta EO over EI for the multiple gauges by the delta EO over EI for the single gauge, that is the definition of our bridge constant. All right. So if we do that, in this case, we would get both of them would have the gauge factor epsilon A over 4. Alright, and the only thing that's different between them would be the 1 plus V. So the gauge factor and the epsilon A within the equations, these would all cancel out. Alright, and we'd be left with our constant would be 1 plus V. Okay, so, alright, so big picture, by using two gauges, alright, in this arrangement, we increase the output of our strain gauge across our Wheatstone bridge. So we would get additional sensitivity if we use two strain gauges within our setup instead of one strain gauge within our Wheatstone bridge. So you can use this same method that we just discussed in this example for different arrangements of strain gauges to determine what the expected bridge factor would be for due to an applied stress. All right.